Hey Prob-Stats students, this is Mr. Mitchell. We're looking at experimental design. We're going to talk about how to design a proper experiment. We're also going to look at some other sampling methods just to make comparisons. So let's go ahead and get started. So we're planning a statistical study. All right, you need to collect data some way or another. You need to identify the individuals of interest. That could be people, that could be cars, that could be animals, that could be anything. But you have to, what are the individuals of interest? What are the specific variables that you're going to measure? All right, what are we looking at? Are we looking at gas mileage of cars? Are we looking at weight loss in a diet? What are we looking at? Okay, there could be one variable, there could be many variables. We have to identify those things. And in a weight loss program, I said diet before, maybe in a weight loss program, you have your diet, you have your exercise, you have some maybe sleep. There's different variables that weigh into that. Are they a stay-at-home worker? Or do they work, 9 to 5? That could be a variable. We don't know. So we have to identify those. Protocols. What are our protocols and procedures? What are we going to do? How are we going to collect this data? In an experiment, there are certain things we must do, and in a sampling, there's certain things we must do. So we just have to be aware of what those are. Okay, so if we're doing a sampling method, decide which one is appropriate. Stay away from convenience or voluntary response. We don't want those. They're no good. Going back to the weight loss one, if people are willing to participate, it usually means they feel somewhat confident about themselves and maybe they don't have to lose as much weight as somebody else. So then that's not as good a representation. Then we need to collect the data. That's important. So we need to use descriptive and inferential statistics to make decisions. Recall that descriptive statistics are just when we find facts. We find statistical facts like what's the mean, what's the median, what's the standard deviation. That's descriptive. Nobody's going to argue what the mean is. Like, here's the mean, this is what it is. Inferential statistics is when you try to infer things. Now, different people could look at a mean and standard deviation and infer two different things. That's why sometimes in politics, one side sees one thing, one side sees another. That's just an example, but there's a lot of other ways that people see different things from the same exact types of data, but that's when you're trying to infer things. It's hard to argue if the mean is 25. The mean's 25. Now, what does that represent? Then that's a different question. Just got to be aware of any concerns and then make recommendations. Were there any issues when you were collecting the data that you want to be aware of, and what do you recommend? The methods of producing data. We can take it from a census. That's the whole population. We can sample. Remember, that is a subset of the population. We can run a simulation. Typically, when we know a simulation, we know what the general outcome should be, but we're going to simulate it to see if it models that. Observational study, we're going to observe and collect data that way. We're not actually imposing a treatment, though. And an experiment. An experiment, the difference between that and an observational study. An experiment, you're imposing a treatment. You're giving somebody blood pressure medication. You're giving somebody a weight loss pill. You're imposing something on them. It doesn't have to be medication, but there is something that's being forced upon them. Not necessarily something that they don't want, but there is a treatment. Okay? And again, this kind of highlights those definitions a little bit that I talked about. Okay, when you are doing an experiment, you must randomize two treatments. I'd say, well, if you're doing one pill for blood pressure medication, how can you do two treatments? You always have to have a placebo in experiments. And that is because it's called the placebo effect. If I know I'm taking a certain pill to help me, my mind might tell me that I am doing better. If I know I'm taking a weight loss pill, I may eat healthier and exercise more, and then thus can we tell whether the weight loss pill actually worked? We don't know because there's too many other variables and there's no placebo. So the example, we need to divide your group into two. One group will actually receive the weight loss pill. The control group received the placebo. It's a fake pill. They think they're taking a weight loss pill, but they're not. It's really just a sugar pill. It's nothing. It's just blah. It doesn't do anything. It doesn't harm them. It's nothing. It is absolutely nothing. It's just an empty pill of nothing. So that way, if these two different groups, if they're still exercising and eating healthy, you can measure to see whether the weight loss pill actually worked more. If two groups are exercising and eating around the same, maybe not exactly the same, but approximately the same amount, and they're both doing the same things otherwise, you can measure to see whether the medicine actually made them lose weight. Because if the group that's taking the placebo doesn't lose as much weight, then you can say that the weight loss pill works. If they lose about the same, the placebo group and the treatment group, well, then the treatment doesn't really work. It doesn't do anything. So then why would anybody take the pill, the real pill? After the treatment cycle, conditions of the groups are compared. You have to compare the results. So what you're trying to do is you're trying to eliminate lurking variables. Lurking variables are things that are outside that may contribute to something else. An example of that in education is test scores. It's not always just, this is what the student learned. There's a lot of other lurking variables that can cause issues within the test scores. Example could be just whether the student had breakfast that day, whether the student is having a rough week. The student may have learned a lot all year and knows the material, but for some reason, maybe something happened in their lives. Maybe somebody just passed away and they're not really, their mind isn't on a test at that point. So are they going to do as well as they normally would have? Probably not. So there's other variables that contribute to those kind of things. So we just need to be aware of that. Double blind is when nobody knows who is the placebo group and who is the treatment group. Now, my example for the weight loss group, a double-blind experiment doesn't really matter because we're going to measure your weight on a scale. That's very objective, meaning it's cut and dry. If you lose 10 pounds, you lose 10 pounds. There's not much to discuss there. It's not, well, that's a different 10 pounds than somebody else's. 10 pounds is 10 pounds. So it's cut and dry. Double-blind is important whenever somebody has to judge something. Example of that would be like an ADHD medicine or something like that. So the observers, when they're observing the children that are needing this medicine, if they know who has the actual medicine, they may be more likely to say, oh, they are acting in a more appropriate manner, they're being less fidgety, or whatever other signs or symptoms that they look for. And if they know this other child or this other group of children has taken the placebo, well, they may be more likely to say, oh, they haven't changed at all. They're the same exact child. They're just as fidgety, just as hyper. So double blind in that example is great because the person observing the children doesn't know whether each child has had a placebo or the actual treatment. So they're just going to do a before and after, and they don't know whether they've had any change or not. That's a subjective concept. So the person doing the observing is subjectively deciding, has there been a change? It's not cut and dry where I lose 10 pounds, I lose 10 pounds. There's not much to argue with that. You lost it. Boom, the scale said it. If I weighed 180 to start and now I weigh 170, boom. There's not much to argue with that. So we want to always prevent bias in sampling and experimentations. We don't want inaccurate results. We've got to use a control group of some kind. Usually it's a placebo. Sometimes it's a different kind of control group, but usually it's placebo. We need to assign individuals randomly to groups. With my weight loss example, if there's different people, depending on how overweight they are, maybe somebody's 30 pounds overweight, maybe somebody's 10 pounds overweight, maybe somebody's 100 pounds overweight, we can't decide which group they go into. That will create bias and inaccurate results. So I need to give them, all the people that are in my study or in my experiment, a number. And then I need to randomly assign them. We've talked about that before using a random number table or a computer generator, or our calculator will also do it. But I need to give everybody a number and then randomly assign them. And that way there's no bias on which people got in which group. We can't do that either, because then that could set us up for having inaccurate bias results. Talked about lurking confounding variables already. Sometimes they're known, sometimes they're unknown. There might be an underlying cause of a change. Somebody may have lost weight for some other reason, in my weight loss example. So we just need to be aware of lurking variables. I said about exercising and diet. You can't have one group on the weight loss pill exercising and eating healthy, and then the placebo group not exercising and eating whatever they want. Those are lurking variables then, exercising and then diet. Well, that's not going to tell you anything about your weight loss pill. When we do that, we have to make sure that the exercise is pretty much the same between each group. Can it be exactly the same? That's tough to replicate sometimes. And then their diet. They have to be eating somewhat healthy for this to be able to compare. All right, so we need to make sure we have a control group, but then that there's other things that are controlled so we don't have any lurking or confounding variables. Potential problems. We don't want voluntary responses. Again, the extremes are who are going to respond if you let voluntary responses. Just like anything else. People that are very, very happy or the people that are very, very, very upset. Those are the ones you hear from. You don't hear from everybody in the middle. And that's typically who we need to hear from. So, non-response is one of these, a hidden bias, because of the way data is collected. Okay, so we have to make sure we're collecting data correctly so there's no bias. So, we've got to make sure we identify any possible issues before we start. What are some other variables that we may not know that could be potential issues? And we can't always generalize our results. We'd like to do inference from this, but sometimes it's not possible. Okay? So we need to make sure that we are doing our experiments with 2 treatment groups, one as a placebo control group. The placebo group doesn't have to be giving a medicine. The treatments don't have to be medicine. Those were my examples. We just have to make sure that there is a treatment and then a placebo to be able to compare them. The treatment could be to other things, could be diet. That could be the treatment, your diet. And then a placebo group would be comparing somebody's diet with somebody else's diet. This group keeps their normal diet. This group keeps has a special diet. We're going to compare the two, but we have to make sure that all other variables are then contributed. We can't change their amount of exercise. So those are just some issues that we need to be aware of, potential problems. We'd like to control them all. Probably can't always control them. Just got to be aware. All right. Any questions? Let me know.